Now we will solve problems based on EMF equation of an alternator. Problem number 1. A 3-phase 6-pole star connected alternator has 48 slots and 12 conductors per slot on armature. If rotor rotates at 1200 rpm and flux per pole is 0.3 Weber, calculate the EMF induced in the armature. The coils are full pitched and winding factor is 0.95. In the solution, first we will write given data. Alternator is 3-phase. There are 6 poles. The armature winding is star connected. Number of slots on the armature 48. In each slot 12 conductors are placed. The speed at which rotor rotates is 1200 rpm. Flux produced by each pole is 0.3 Weber. Kc, that is coil factor, is equal to 1 since coil is full pitched. We have seen that for a full pitched coil Kc is equal to 1 in the last video. Winding factor is given as 0.95, which means that winding is not concentrated, instead it is distributed type winding. Knowing N is equal to 120 F upon P, you can write here synchronous speed, because alternator runs at synchronous speed. N is equal to 120 F upon P. F is equal to P into N divided by 120. So this is 6 into 1200 divided by 120. Cancelling this, we get frequency as 60 Hertz. Next we need to calculate number of turns per phase. For that we must know the number of conductors per phase. So first we will calculate the number of conductors per phase. Number of conductors per phase is equal to total number of conductors divided by 3, and total number of conductors is calculated as number of slots into conductors per slot whole divided by 3. That is Number of slots is 48. In each slot there are 12 conductors. Now divide this by 3. We get 192 conductors per phase. Therefore, turns per phase is equal to 192 by 2, 96. Now we will calculate phase voltage. EPH is equal to 4.44 phi F T into Kc into Kd. That is 4.44 into 0.3 into 60 into 96 into 1 into point the 95. Simplifying, we get 4.44 into 0.3 into 60 into 96 into 0.95. $7,288.704 volts or 7.288704 kilovolts. Line voltage EL is equal to root 3 EPH. So root 3 into 7.288704 kV, that is equal to 1,200, that is equal to 12,624.40 or 12.62440 kV. We will solve another problem on this EMF equation. In this problem number 2, a 3-phase 16-pole three-phase, number of poles is 16. 16-pole alternator has star connected armature winding with 144 slots. Slots number is 144. There are 10 conductors per slot. The flux per pole is 0.03 Weber. Speed is 375 rpm. Find the frequency and EPH. After that, EL. Given Kp equal to 1 and Kd equal to 0.96, which means that coils are full pitched and the winding is distributed type. We'll first calculate the frequency. Knowing synchronous speed n is equal to 120 f upon p. You can write f as n into p divided by 120. 375 into 16 divided by 120. 50 hertz. Next we will calculate total number of conductors. Total number of conductors is equal to number of slots into conductors per slot, that is 144 into 10, that is 144 into 10, which is equal to 1440. Number of conductors per phase is equal to 1440 divided by 3, that is 480. Turns per phase is equal to 480 divided by 2, that is 240. Symbol for turns per phase is T. EMF per phase, that is EPH, is equal to 4.44 phi into F into T into Kc into Kd. Substituting for various values, 4.44 into 0.03 into 50 into 240 into 1 into 0.96 will be equal to becomes 1534 0.464 volts. Line voltage EL is equal to EPH into root 3. So 1534.464 into root 3 will be equal to 2657.76 volt or 2.65776 kV.